Hello guys, welcome to the next lecture on the PY question series. Today, based on your several requests, I started this Maxima and Minima lecture in this video. Myself Dr. Harish Garg, you can simply follow my YouTube channel where you can find the playlist of the GATE mathematics and the playlist of the IIT JAM solution, and you can find the various PY questions series. So let me tell you how you can solve the problem. For example, if you have the function of a sin x plus b cos x, how you find the maxima and minima? You always take the first derivative 0, second derivative should be greater than 0 and less than 0. But I will tell you there is no need of this one. What is the shortcut tricks? Whenever you have of this function, then the maximum value you can obtain by using this root a square plus b square. Minimum value is minus root a square plus b square. This is my shortcut trick 1 for you. Another is, this question is usually asked in the statistics, GATE statistics as well as the IIT JAM mathematics. How you can solve that? Generally, you will solve this problem by using the Lagrange multiplier like of this. Fine. And then you can take the first derivative 0, second derivative should be here. But again, I will tell you there is no need of that. You can convert this equation into the polar form. Whatever is there, whenever the objective function is a linear, you can apply this trick. So what is the polar form is x is equal to r is my 1 cos theta, and y in this case is 3y is r sin theta. I can substitute this value here. My z will be cos theta plus 2 into y, so that will be 2 over 3 sin theta. Now clearly say this is of this form and you need a minimum. So what is the minimum is minus a square plus b square. What is the a is 1. So 1 plus 4 over 9. So after the calculation you will get the right answer. Similarly for here you can change into the polar form. So x is my 2x, radius is my root 5. This is cos theta and 3y is root 5 sin theta. So what is the value of the z? Z is my 3x. So 3 root 5 over 2 cos plus 2 into y. So 2 root 5 over 3 sin theta. So what is the value of the maximum? Again, it will be 9 into 5 is 45 over 4 plus 4 into 5 over 9. So you can solve this. Whatever the solution you can get after the calculation is the right answer. You can see this is the way you can solve each question in a simple manner. Second shortcut tricks. Check whether the function is symmetric or not. Whenever the function is symmetric, the maximum and minimum always occurring at the point x is equal to y. For example, how you can check the function is symmetric? If f of yx is same as f of xy, or you can say if you replace x to be the y and y to be the x, the function remains the same. Then you can say the maximum and minimum always occurring at the point x is equal to y. On the other hand, if your function is not symmetric, then how you can find the maximum minima? I can obtain the critical point here. After getting the solution, we can get the x comma y. Then always draw this Hessian matrix. What is the Hessian matrix is? It's a very simple. You can see fxx, fxy partial derivative, yx and fyy. Then you can define the two values d1 and d2 from this. d1 is my first value. Fine. d2 is my determinant of this matrix H. And if you obtain that both the values are my positive, like here, these both values are my positive, then is the point is minimum. If the first value is negative, other value is my positive, then you can say it's a maximum point. Also, if you prove that this condition hold, then it equivalently means that the function is my convex, and this also means it's a concave. All the other cases which are not satisfying this property is called as the saddle point. Fine. The first one is, if the first value will be 0, then you can say the saddle point. If d1 is greater than 0, d2 is less than 0. Is it satisfied? No. So then again this is my saddle point. Now based on this simple trick I can solve each PY questions easily. Okay, so your first target is always to check whether the function is symmetric or not. Yes, it's a symmetric. So once it's a symmetric, you can see the solution will be here. It's a 3 dimension. So what is my f when x is equal to y is equal to z is x cube. How you can find the value of x? I can substitute this value at here also. So this is my x square. Second value is also x square. This is x square. Minus of a is 0. So can you find the value of x is a over 3 raised to power 1 over 2. I can substitute this value here. You will get the right answer as this one. No need to apply the Lagrange multiplier method or any other approach. Whenever you find the symmetric, solve like this way. Check whether the function is symmetric or not. Yes, it is a symmetric because if you replace x to be the y and y to be the x, function is same. So my solution is obtained by using x is equal to y. So substitute it. It is x square over 2 plus 100 plus 100, 500 plus is my here. How you can find the maximum minima? First derivative should be 0. So it is x minus 1000 over x square is 0. So what is the value of this? X cube will be my 1000, x will be 10. I can substitute the value of the 10 at here. So it is 150 is the right answer. Check whether the function is symmetric or not. Yes, it is a symmetric. So the solution is obtained at x is equal to y. So my function will be x square and x square is a 3x square plus 2 over x. First derivative to be 0. 6x minus 2 over x square is 0. So 2 I can cancel out. Is a 3x cube minus 1 is 0. X cube will be 1 over 3. Now if you look at that, he said the maximum minimum value occurring at a is equal to b. That means a is equal to b because it's a symmetric. So a is my x. So basically x cube is my 1 over 3. So b cube is also 1 over 3. So what is the sum of this? 2 over 3 is the right answer. Check whether the function is symmetric. No, it is not symmetric. Fine. So once the function is not symmetric, you can write this function fxx, fxy, fyx, fyy always. Okay. Always draw firstly calculate the h. So what is that? What is that? If you calculate the second derivative of the x, it will be my 6y, fine, minus 6. What is the value of this? F of xy. So it's a 6xy minus 6x. What is the derivative of this with respect to x? Y is here. This is also my this. It will be my 24y minus 24. Fine. Now, saddle point. What is the definition of the saddle point is? The first value should be 0. So once it will be 0, it means y should be 1. Fine. Now, once the y is 1, so this option and this option is cancelled. Clear? Look at this another one. How you can find the x, whether this or this? So I can find the first derivative with respect to x is 0. What is that? It is my 6xy minus 6x is equal to 0. I can substitute y is equal to 1 here. It will be 6x minus 6x 0. You are unable to compute. What is the fy is 0? Fy. So 3x square plus 12y square minus 24y is equal to 0. I can substitute y is equal to 1 here. It is 12 minus 2 here. So what is the value of the x? Plus minus 2. So you can see the 1 value is here. This value is cancelled out. So D is my right answer. Is the function is symmetric? No. So I can find the value of the h. So first one is the second derivative with respect to x. So cos and again it's a sin x. This is 0, this is 0, it is my 2. Then the critical point maxima, minima and here. What is the f of x is 0? It will be minus 4 cos x is 0. So what is the value of the x in this domain? pi over 2, 3 pi over 2. What is the fy is 0 means? 2y is 0. So that means y is equal to 0. So you have the 2 point pi over 2 comma 0, 3 pi over 2 comma 0. So I call this point is my A, this point is my B. So what is the value at the point A? Sine pi by 2 is a 1, 0, 0, 2. So what is the value of the D1? First value 4, D2 8. So this is greater than 0, this is greater than 0. So you have a minimum point. What is the value of the B? H, 3 pi by 4, 3 pi by 2, it's a minus 1, 0, 2 and here. What is my D1? Minus 4, less than 0. D2, minus 8, less than 0. So remember, whenever D1 is less than 0, D2 should be greater than 0. It is not satisfied, it means it is a saddle point. So how many you have obtained? Minimum and saddle. So maxima you can never obtain, maxima never obtained, maxima never obtained, minima and the saddle. Is the function is symmetric? Yes, it's a symmetric. So the solution is obtained at x is equal to y. But remember, you are talking about the saddle point. Whenever x is equal to y is needed, then whenever you have to find the maxima and minima, then you can substitute this value here. But right now we are talking about the saddle point, so you can find this h always. What is the second derivative of this? 3x squared 6x. Fine. This value is my 2, this is 2 and it will be my 6y. What is the definition of the saddle point is? The first value should be 0. That means x must be 0. So this option will be cancelled out, and because it's a symmetric, so must have the x is equal to 1. The number of the critical points. What is the definition of the, because now they are not asking you the maxima and minima, so there is no need to write the h. First derivative should be 0, fy should be 0. What is the first derivative of this? I have to apply the uv. So first function is 2x e raised to power this function plus x square plus 3y square e raised to power minus of this into minus 2x. It should be 0. So I can take that 2x common, e raised to power this value is a common. So inside is 1 minus x square minus 3y square is 0. Look at the fy is there. So fy will be my 6y e raised to power minus of this plus x square plus 6y square e raised to power this and minus 2y is 0. So I can take that 2y e raised to power minus this common. It will be my 3 minus x square minus 3y square is 0. So what you obtained from this, that means either x is 0 or x square plus 3y square is 1. From the second one is either y is 0 or x square plus 3y square is 3. Clear? Now how you can find the critical points. So the number of the critical points, how many pairs are there? The first pair is 0, 0. Second pair is when x is 0, what is the value of the y is? Plus minus 1. Second pair is when y is equal to 0, this pair is 0, it's satisfied. When y is equal to 0, x is my plus minus 1. And can you solve these equations? It is not possible. So how many points you have? 1. It says that 2.2 plus 2 plus 1, that is 5 is the right answer of this problem. So you can see it's a very simple answer that you can got it from this case. Okay, look at this one. A function is given to be here, x minus 2 raised to power 17, x plus 5 raised to power 24. Okay, firstly I can give you the tips. Whenever you have the function of the single variable fx like here, then find the values at point 0. That point come to be here. Fine. Then look at the value. Okay, I can explain you by this example. So critical point is already given that 2. Fine. So it means I can found this value as 2. Find the f dash. Fine. because I have to consider only the point 2, so this value will always the positive. Fine. What is the derivative of this is x minus 2 16, and what, because this point 2 does 2 for at x equal to 2, this is always the positive, so I can say k. Now look at that, whenever you have considered x is less than 2, any number which is less than of 2, can this number is positive or negative? Is a positive always. When you take x is greater than 2, this number is, take any number x greater than 2, say 3, this number is also positive. So you can see there is no change in the sign. Fine. When there is no change in sign, we can say it is a saddle point. So that means it does not have a neither the minimum nor the maximum is the right answer. Where there is a critical point, okay, what is the critical point definition for you? The first derivative should be 0, the first derivative should be infinity. Fine. All those points which satisfy this property is called as the critical point. So clearly say if you take the first derivative, it will be 17 x minus this, and this point is my constant. Fine, because we are talking about the point 2. Otherwise you can find this value also, plus 24 x 0.5 23 of this. So clearly say 2 will be the critical point. So this case neither the maxima nor minima, because it does not change the sign. When it will be the maxima minima, I can again tell you here. So if at some point x naught, if this value is say negative, this value is my positive. So it means the firstly value decreases and then increases, it will give you the minimum value. On the other hand, if this value is my positive, this value will be my negative, then you will get as the maximum point. Means that point will be my maximum, that point will be minimum, that point will be my neither maxima nor minimum. Okay, look at that. The total number of the point at which the function is maxima and minima. Can you find the derivative of this? What is the derivative of mod x? X over mod x. So I can say this is x square minus 25 over x square minus 25 into derivative of this part. Now, what is the definition of the critical point? F dash should be 0 or f dash should be infinity. So for what value of that and which x f dash should be 0? 0, 5, minus 5. When it will be the infinity? When it's a 5, minus 5. Fine. So how many total points are there? Or you can say this value is either the plus 1 or the minus 1. So there is no point at here. So the number of the critical point is my 3 is the right answer. Fine. If I say the function is my 1 over x, for example, what is the critical point? You can find the derivative is a minus 1 over x square. Okay. So clearly say f dash 0 is not possible. At which point is infinity? X is 0. So 0 is my critical point of this example. Okay, look at this one. Is a local maxima minima for n is even and odd. So I can simply choose n is my 2. Fine. So my function is x square sin x. Now at x is equal to 0, I can check whether the maximum, because it's a single variable. Once it's a single variable, there is no need to write the h. So what is the derivative of this? It is my 2x sin x plus x square cos x. Now look at the any value which is less than of the 0. Say x is minus 1. So this value is a negative. This number is negative. So whole term is my positive. This number is my positive. Cos negative is also positive. So this number is my positive. Take any number which is greater than of the 0. So say x is equal to 1. So this is positive. Sin 1 is a positive. This is a positive. This is positive. What does it mean? It is a neither the maxima nor the minima. That means it's a saddle point. So when n is even, it's a maxima cross. When n is even, minima cross. Now take n is odd. Let's say n is equal to 3. So x cube sin x. Find the first derivative. 3x square sin x plus x cube cos x. Now at the point 0, take any value which is negative. Say minus 1. So this value will be negative. this number is positive, so whole term will be my negative. This is my negative, this is my positive, the whole term will be my negative. So this number is negative. When you take any of the x is my positive, say 1, it is the positive, this is the positive, so complete is my positive. So you can see what is my shortcut test for you, where this is once is a negative and is a positive, you will get as the minimum value. So this point is my minimum arc. So that's a local minimum. So this is my minimum, maximum is cancelled. Okay, look at this one. A function is defined on the closed interval -1 to 1. The maximum value occurring at here. I can firstly found the f of -1 plus 1. What is the f of 1 is? Half plus 1, 3/2. What is the f of -1? Again, it's a 1/2. It's my 2, it's a 1/2. It is my 1. Now again the point is half is also given. So what is the f of half? It is my half, it is my 2/3 plus this is my half, it's my 2/3. So it is 4/3, means 1.33. This is 1.5. So clearly say this will never be a maximum. Is it maximum? No, because we get a maximum at 1.5. So this is the maximum, cancel out. Now that's over. Minimum value is 1/3. 1/3 means 0.33. Maximum value is 1.5 and minimum occurring at 1. So what is the value of the 1 is 1.5. But we can obtain the minimum also as 1. So this value is also cancelled. Now minimum value is 1/3 and maximum value is 1.5. So how you can find that? Very simple again. You can see from this case mod of x is less than equal to 1. So what is the 1 plus mod x? It is less than of 2. So 1/1 plus mod x is greater than of half. Is it fine? Now we can see about here. -1 less than here. What is the x minus 1? It is 0 minus 2. What is the mod of this? It is lies between 0 to 2. If I add 1, it will be 1 plus here. And if I take the reciprocal, it is 1/3 of this is my here. Clear? Now clearly say if I add them, if this number I can return, this is half 1/1 plus mod x less than of this. So this is this. If I add them, it will be my 5/6 less than of this. So the minimum is occurring at 5/6, but he said this is cancel out. So the maximum value is occurring at 3/2. That's a 1.5 is the right answer of this problem. Okay, now look at that, the maximum value of this. Now it's not a linear. So what I can do is a very simple. I can find the value of the x from here and substitute in this case. Fine. Now it's a single variable, so I can take the first derivative to be 0. So it will be -6 10 minus 3y minus 2y is 0. So 30, I can divide it by 2 firstly. So 30 minus 9y minus y is equal to 0. So y will be 10 3. So I can substitute here. What is my f? 49 9 1 9. So it's a 10 39 is the right answer. You can see how many seconds you are needed, just a fraction of second. Again the similar case, I can substitute the value of the, if I found the value of y, then if I substitute here, it will be the square again. So better I can find the value of the x square. It is y plus 1. So I can substitute here y plus 1 plus 2y square. So f dash will be 0. So it is 1 plus 4y will be 0. Y is minus 1/4. I can substitute here. It is minus 1/4 plus 1, 2 into 1/16. So it is 1/8. So 8 will be the LCM. Minus 2 plus 8 plus 1/8. So 9 7/8 is the right answer of this. problem. Okay, look at the function here. If you remember my previous lecture, what I gave you the tips is whenever you have this form, fine, when it will be the continuous, when m is my greater than 0, when this function will be differentiable, when m is greater than of n. Now look at that, fx over f. So can you find the fx over f firstly? It will be x square sine 1 over x. So is it a continuous function? Yes, because m is a 2, 2 is my greater than 0. So once it's a continuous function, what is the limit of this function? It will be goes to the f of 0, means this function as a 0. Okay, or then if you don't want to remember the concept of the continuity, you can apply this definition. What is that? This is my bounded function when limit is at 0. So we need a false statement. This is the correct statement. What is the fx over x square? Again, when you take the x square, it is x sine 1 over x. So clearly say m is my greater than 0. It's a 1, it's a greater than 0. So what is the limit as x approaches 0? Again, it's a bounded function, so it goes to the 0. F of x by x square. What is the f of x is x square is x sine 1 over x has infinitely many maxima and minima in the interval 0, 1. That's again a simple, we all know what is the graph of the sine 1 by x. It will be like here. So if it is my 0, let me draw it clearly. Okay, fine. So say this is my 1, this is my 0. Now you can see how many maxima minima are there. 1, 2, 3, 4, 5. Okay, if you want to do like this way more, so definitely it will give you the infinitely many maxima and minima. So this option is also correct. This, the left option is my here. But how you can check about this option, the last option, again I will tell you this, because they are talking about the continuity and differentiability, I can use this concept. What is the fx over x4? What is that? It's a 1 over x sine 1 over x. Is it a continuous? No. Why? The value of the m is my -1, which is not greater than 0, but he said continuous, so that option is wrong option. Is it a differentiable? Again, it is not differentiable, because in this case m is my -1, n is my +1. So -1 is not greater than 1, so it is not differentiable. So this option is the correct. This part is correct, but the function is not continuous, so that's why D is my right answer. The minimum value of this, check whether it's a symmetric. No, it is not symmetric, so you can find the firstly h. What is the second derivative of this? The first derivative will be 2x plus y minus 3. It will be my 2. Then it's a constant number. Okay, fine. What is the second derivative of this? Is a 1. What is the y with respect to x? It's a 2x plus y minus 3. Fy will be x plus 2y minus 6. So it will be my y with respect to x, and it will be my 2. Fine. So clearly say it will be my 2 greater than 0. D2 is the determinant of this. So when both are greater than 0, it is my minimum. So what is the point minimum value? Can you solve this? If I substitute this as a 0, 2x plus y is equal to 3, x plus 2y is equal to 6. So I can multiply by 2 and subtract them. So minus 3y is a 12 minus 9. Y is equal to 3. So when y is equal to 3, x will be 0. So I can substitute this. What is the value of this? When x is 0, this value is 0, this value is 0, this value is 0. So y square 9 minus 18 plus 11. So minus 9 plus 11, 2 is my right answer. Okay, the function is symmetric? Not. So the critical point you can write as a h. So is the point of maxima and minima and here. So firstly I can find this fx is 0. It will be minus 2 times alpha plus beta times of the x, and 3 x square is 0. What is the fy is 0? With respect to y, 2 beta y plus 3 times alpha plus 1 y square is 0. Then when x is equal to 4, if I substitute x is equal to 4 here, because these are the critical point, it must satisfied here. When x is equal to 4, it is minus 8 alpha plus beta plus it's 1648. So that means alpha plus beta must be 6. Fine. So that's satisfied, but it doesn't mean that alpha is 4 and beta is 6. I can check about here. 0 is not there. So when I substitute y is my minus half, it will be minus beta plus 3 over 4 alpha plus 1 is 0. So is it satisfied this point? I can check it. Minus 2 plus 3 over 4, 4 plus 1. Is it 0? No. So it means this option is cancelled. Fine. Now, so now we can find the h. So what is the second derivative with respect to x? This is the first derivative. So minus of 2 alpha plus beta, x 0, 0, and it will be my 2 times beta plus 6 times alpha plus 1. Now look at the point of this. At this point, when x is equal to 4, so alpha plus beta is my 6. So it will be my minus 12, 0, 0, 2 beta plus 6 alpha plus 6. Fine. So look at that. The first value will be my less than 0. It means it can never be the minimum. Why? Because if it is a minimum, we need both the values are greater than 0. But you can see it's a minimum. Cancel out. Now, what is the value of second minor? The D2. You can see the sum of them will be the 6. Fine. And both are my real numbers, so it will be minus 12 times of this. When it will be the maxima, if you prove that D2 should be greater than 0. So can you find the value of alpha and beta? So from here, can I find the value of this? So what is the alpha plus 1 from this? It is 7 minus beta. Fine. So it is minus beta plus 3 over 4. 7 minus beta is 0. So can you find the value of beta? Is 7 over 4. Beta is minus 21 over 4. So clearly say beta will be my 3. So once beta is 3, alpha will be 2. So I can substitute here. This number is my positive. Once this is the positive, if you multiply them, it's a positive number. So it's a less than 0. What does it mean? It is a saddle point. So neither the maxima nor the minimum. Is the function is symmetric? No. So you can find the h firstly. What is the second derivative of this? With respect to x, minus 4. With respect to, okay, firstly I can write here is fx will be 4y minus 4x. Fy will be 4x minus 4x cube. So fxx, fxy, 4 minus 12y square. Now clearly say when the first value is my minus 4 less than 0. So can it be the minimum? It can never be the minimum. Is minimum cancel out. Minimum cancel. Now, so D1 will be minus 4. What is my D2? It's a 48 y square minus 16. That means 16 times of this. Fine. So how I can find? I can substitute this as a 0. From here I can got x is equal to y. From here I can got x is equal to y cube. That means y is equal to y cube. That means y will be my either 0, either plus 1 or minus 1. Fine. So now I can check at the points B. So when at the point 0. Fine. What is the D2 is? Negative. So first one is negative, second one is negative. It means it's a saddle point. So one saddle point we have obtained. Fine. At x is equal to plus 1, this number is my positive. So once is a negative, second is the positive, that means we will get as the maximum point. So one maximum point we have obtained also. When x is equal to when this is a minus 1, this is also the positive, so we get one maximum, one saddle, two saddle point cancel, one maxima, one saddle is the right answer. Is it symmetric? No, it is not symmetric. Point is already given to you, so I can define as the h. So what is my fx? 6x power 5 minus 4xy, 4x cubed y, and fy will be minus 2x square minus x4 plus 4y. Fine. Now if I substitute, what is the fxx? The first value will be here, so it's a 30 x4 minus 4y minus 12x square y. So clearly say at the point of the origin, what is the value of this? 0. So once the first value will be 0, what does it mean? It's a saddle point. So it has a local maxima cross, minima cross, origin is not the critical point. Clearly say 0. If I substitute this as a 0, clearly say 0 and 0 satisfied. So C is the right answer of the problem. Okay, look at this another one. The function is given to you and the point is given to be here. Fine. So again, it's a very simple. How you can solve that? Okay, D and E. So firstly I can solve for this. F is my x square plus 2y square minus x. The point is x square plus y square of this. What is my h? 2, 4, 0 and 0. So what does it mean? It is give you a d1 is positive, d2 is positive, so it will give you the minimum point. Fine. Now how you can check about that? So it's equality. So I can start from x square plus y square is 1. So I can substitute this value here. What is my function? It will be 1 plus y square minus x. I can substitute the value of the y square here. It is 2 minus x square minus x. I can got the value as first derivative to be 0. Minus 2x minus 1 is 0. So x will be minus half. When x is minus half, what is the value of the y? Y will be from here. So y has the two values because we need a total number. So what is the point is minus half plus minus. Fine. And at this point, what is that? We will get as minima because from the h we got as the minima. Fine. Now similarly, this is for the point of the D. D minima is my how many point? 2 points. So D minima is my 2 point. Can you obtain the maxima here? What is the D maxima? Okay, you can similarly absolute maxima. Similarly for this case, how you can find the value? I can, okay, just wait. Is the maxima or minima? What is the second derivative is? Second derivative is my minus 2, which is less than 0. Sorry, this point is my maxima. Fine. So D max will be my minus half plus minus whatever the value of this. Now I can do the same thing for my this case. So it is my x square over 4 plus y square over 9 is my 1. So what is my f? I can substitute the value of y square. I can substitute the value of y square. So it's 1 minus x square over 4 into 9. So 9 to 18 minus x. So I can take the first derivative to be 0. It is my 2x plus 18 minus x over 2 minus 1. So it is my 9. So 7x minus 1 is a 0. So x will be minus 1 over 7. 1 I substitute x at here. Again we will get y as plus minus two things. So we will get as minus 1 over 7 plus minus of two things. Fine. So what is that? And again, what is the second derivative of this will be? It is my 2 minus 9, which is less than 0. So you will get also as E maximum. How you get the minimum, and from here you can get as minimum. So I can get as fx is 0, 2x is 2x minus 1 0, and 4y is equal to 0. So the point is half comma 0. So we get half comma 0 is 1 minimum, and this minimum is for both D and E. So now your target is to find the union. So this is my 2 solution, this is my 2 solution, this is my 1 solution. So how many solutions are there? There are 5 solutions. Because if you write 2 times here, 1 for the D and 1 for the E, and the union will always be the single one. So the right answer is 5 is the right answer. Okay, the global minimum and maximum of this. So clearly say this is a square which is always be the positive number. Fine. Now I can break this portion whenever x is less than 1, whenever x is greater than 1. So whenever x is less than 1, it will be 1 minus x here, and whenever x is plus 1 greater than 1, it will be here. So then the global minima. So what is the minimum is, you have to take the first derivative to be 0. It is minus 1, 2x minus 4, whenever x is less than 1, 1 plus 2x minus 4, it should be 0. Fine. So I have the 2 cases. From the first case, it will be 2x minus 5 is 0. From the second case, 2x minus 3 is 0. So we have 2 values, this and this. So I can substitute this value at here. What is my f? 5 over 2 minus 1, 3 over 2, 5 over 2 minus 2, 1 over 4. So it is my 6 plus 7 over 4. When x is 3 by 2, then when x is my 3 by 2, it's 1 over 2 plus 1 over 4. So it is 3 over 4. Your target is to find the minimum. So minimum is 3 over 4 is the right answer of this problem. That is a 0.75. Okay, look at this another one. It's a 2023. Qx is my here maxima and minima. Problem look like it's a very complicated, but trust me, is one of the simplest one. What is the meaning of this? Q is my px plus pj denotes the jth derivative of p. That means the first derivative, second derivative, third derivative, and the 57th derivative. Okay, so it will be, what is the, okay, so it is my x raised to power 57 plus something. This will be my x raised to power 56 something. Fine, then 57 of here. This will be x raised to power 55 something, and so on. So that means q is my polynomial of degree. What is the degree of the polynomial? 57. Fine. So what, or you can say the degree of my qx is 57. What is the nature of this 57 is? Odd degree. Fine. Clear? Now think about that. If I simply take any of the function which is of the odd degree, let's say x, because they are talking on the real line. Fine. So what is the graph of the x cube axis? This is the graph. Can you obtain the maxima of this graph on the real line? No. So it means similarly, if you take the graph of the x cube, this is the odd degree, the graph will be here. Can you obtain the maxima and minima of this function? No. So what is the graph of the x raised to power 57? Again, it will be like of this. So it means you can never neither the maxima nor the minima. So that means neither the maxima nor the minima because of this odd degree. The problem is a very interesting problem, and a solution is also very interesting. Fine. If say for example my polynomial of degree q is say 56, what is that? This is the even degree. So what is the graph of the even degree? Like say x square, this, x4, this. So it means x raised to power 6 is also be there. So you will get as the minimum point. Fine. But in this case it's an odd degree, so that you can get neither the maxima nor the minimum. Okay, look at this another one. Again, is it symmetric? No, it is not symmetric. Is it symmetric? No. So it is not symmetric. The point is given to you. I can calculate the h firstly. Fine. So firstly I can calculate the h for the p. What is the second derivative of this? First derivative will be my 2x over here. The second derivative will be my 2. This value will be x and y. Firstly, first derivative here, and then I can differentiate with respect to y. It's a 3y. Then it's a y with respect to x. What is the y with respect to x is? It's a 3xy is my 3y. What is the second derivative of y with respect to y? It is my first, it's a 0, it's my 2, it's my minus 3x. Is it okay? Now add the point 0, 0. What is my h? This is 2, 0, 0, 0. So what is that? d1 will be my 2 greater than 0. d2 will be my 0 minus 0. It's a 0. So what can you say? Whenever this is, we can't say anything. Fine. So we can't say anything. But how you can say? It means it can never. Can you say it's a maximum or minimum? So we can see about the function. X square minus 3 over 2 xy square. So clearly say y is either the positive or y is either the negative. This number is always positive. So I can start from here 0. Fine. Take any value which is less than 0. Say x is my less than 0, y is my less than 0. This value will be, is it always positive or always negative? You can see whenever x is negative, this number is my positive. Whenever x is negative, this number is my negative. This number is always positive. So because of this negative and this negative, it is always positive. From this case, whenever x is my positive, y is my positive. So this number is always positive. This number is my positive. This number is my positive. So can you say whole number is my positive? No, because you can see it is x square minus 3 over 2 xy square. So this number is always positive. This is always positive. This is always positive. But because of this negative, sometime it is a positive, sometime it is a negative. How? If you simply choose x is my 1, which is a positive, y is my 1. What is the answer of this is 1 minus 3 over 5, which is less than 0. But if I choose x is my say 7, y is my 1. Again it satisfied this property. So it is my 49 minus 21 over 2, which is greater than 0. So what does it mean? If it, what does it means? Neither the maxima nor the minima. That means it is my saddle point. So yes, this option is my correct option. Fine. Now we can do the same thing for this second point. So how you can define h for the matrix Q? So what is the first derivative will be 4x cube fx minus 10xy. So what is the fxx? 12x square minus 10y. Fine. So whatever the values of the other, you can see our target is to find the 0, 0. What is the value of this at the 0, 0? So it means the first value will be 0. What does it mean? Yes, it's a saddle point. Fine. So both are my saddle point is the correct option of this example. So you can see a very simple, always draw the matrix and get the conclusion. Always remember, whenever the first value is positive, second value is positive, minimum. First value is less than 0, second value must be positive, then it's the maximum. Otherwise, we call as the saddle point. So this is the way you can solve all these PY questions in a very simple manner. We will see the next lecture on the linear transformation very soon. I hope you can like, share and comment on my video. Best of luck students. Happy learning.